Let's tackle the elephant in the room. Your Model 3 isn't hitting its advertised range. Independent tests consistently show 20 to 30% less mileage than EPA estimates. This isn't just you, it's a common concern. We'll explain the key factors causing this discrepancy, from driving habits to environmental conditions and battery degradation. Here's a comparison of Tesla Model 3 vehicles showing how range has improved over the years. This graph illustrates battery health degradation, showing how rated range decreases with mileage. Environmental conditions like cold weather significantly impact range, as shown in this winter test. Knowing these issues is the first step to improving your car's efficiency. Your battery's energy is lost in multiple ways. We'll break down the key culprits and how to identify and mitigate each of these losses. Aerodynamic drag at highway speeds accounts for 40 to 50% of energy loss. This occurs when air resistance pushes against the vehicle as it moves forward. Rolling resistance from tires consumes 20 to 30% of energy, worsened by underinflation, which increases friction with the road. Regenerative braking inefficiencies lead to 10 to 15% heat loss, as some kinetic energy is not fully recovered during deceleration. Extreme temperatures are a major factor, with battery heating in cold weather draining 20 to 30% of your range. Even accessories like air conditioning and Sentry mode add up, contributing to additional energy consumption. Tesla has been actively addressing efficiency issues with software updates. The full self-driving supervised version 12.5 uses AI to optimize route planning, tire pressure monitoring, and regenerative braking, boosting average range by 10 to 15%. A voluntary recall addressed software bugs causing unintended energy draw in older models from 2018-2022. To check for and install these updates, open the Tesla app, go to Software, select Software Update, download and install, then restart the vehicle. You can expect 10 to 15% range improvement after installing these updates, with real-time feedback on energy usage via the vehicle's display. Beyond software optimizations, Tesla has made significant hardware improvements to address Model 3 efficiency issues. The 2025 Model 3 refresh introduced the new 4680 battery cell architecture, originally developed for the Cybertruck but adapted for production vehicles. This upgrade improves energy density by 15% and significantly reduces thermal losses, particularly in cold climates where range drops were previously severe. The 4680 battery cell features a cylindrical design with larger dimensions compared to previous cells. Inside, it includes advanced layering with cathode and anode current collectors, aluminum and copper discs welded to the can, and a positive button for electrical connection. This design allows for better energy packing and heat management. To understand the improvements, let's compare the 4680 cells with older technologies like the 18650 and 2170 cells used in earlier Model 3 models. The older cells dispersed heat laterally across the cell, leading to inefficiencies in thermal management. In contrast, the 4680 design allows heat to flow vertically, reducing energy losses and improving performance in extreme temperatures. The 4680 cells provide higher energy density, measured in watt-hours per kilogram. Older Model 3 batteries typically achieved around 250 watts per kilograms. With the new architecture, this increases to 202 to 296, representing that 15% improvement. This means more energy stored in the same space, directly translating to better range. In real-world driving, these hardware changes have a measurable impact. For example, in cold climates where older Model 3s could lose up to 40% of their range due to battery heating needs, the 4680 cells reduce this loss to around 25%. This improvement comes from better thermal management and higher energy density, allowing the battery to maintain performance in harsh conditions. Comparing the models side by side, the older Model 3 with 18650 and 2170 cells offered 250 watt-hours kg energy density with significant thermal losses. The new 4680 equipped Model 3 achieves 272 to 296 watt-hours per kilogram with much better heat management, leading to more consistent real-world efficiency and reduced range anxiety. Your driving style significantly impacts range. How you accelerate, brake, and maintain your vehicle can make a big difference in efficiency. Maintain proper tire pressure at 45 to 50 psi for optimal rolling resistance. Underinflated tires increase energy use by up to 20%. Use Eco Mode to enable adaptive energy consumption features that optimize power delivery based on driving conditions. Avoid aggressive acceleration and braking, which wastes energy through inefficient power conversion and reduced regenerative braking recovery. Precondition your battery before charging and driving, especially in cold weather, to minimize thermal losses and improve charging efficiency. The Tesla app provides real-time watt-hours per mile feedback. Monitor this metric and aim for 250 to 300 watts per mile for optimal efficiency. Here's a checklist of actionable steps you can take today to maximize your Tesla Model 3 range. Consumer Reports conducted range tests on a 2022 Model 3 long range. The EPA rating was 405 miles, but real-world testing showed only 320 miles, a 21% shortfall due to winter conditions and aggressive driving. However, after Tesla's over-the-air software update, the range improved to 360 miles, demonstrating how software fixes can address efficiency issues. In the Arctic Drive Challenge, a Norwegian owner drove a Model 3 from Oslo to Tromsø in -20°C conditions. Initially, range loss was 45% due to battery heating inefficiencies. Using preconditioning and route optimization, the range loss dropped to 25%, saving 50 miles and highlighting the importance of thermal management solutions. A pilot study with Tesla and Uber in California showed Model 3 taxis losing 15% range daily from frequent stop-start driving patterns. Tesla's fleet software update, including predictive charging, reduced losses to 5%, enhancing efficiency and profitability for ride-sharing operations. These real-world examples demonstrate how both efficiency challenges and Tesla's fixes affect everyday driving, from individual range tests to commercial fleet operations. Tesla offers free diagnostics through the app to help identify potential issues affecting your Model 3's efficiency. The app can detect battery degradation and other hardware problems that may reduce your range. If diagnostics show significant issues, schedule a service appointment. Common fixes include software recalibration or battery module swaps under warranty. Tesla's warranty covers battery and component replacements for eligible vehicles, typically up to 8 years or 150,000 miles. Check your specific coverage in the app. The EV efficiency landscape is rapidly evolving, with Tesla leading the way in innovations that promise to solve current range and energy challenges. AI and predictive analytics will further optimize energy management, with machine learning predicting energy needs based on driving patterns and historical data. Solid-state batteries represent a major breakthrough, offering 50% higher energy density and significantly less thermal loss compared to current lithium-ion technology. Tesla continues expanding its supercharger network, with V3 technology providing faster charging speeds and better integration with route planning for minimal downtime. A growing focus on sustainable battery materials, including recycled components, will help reduce battery degradation and align with environmental goals. By 2030, experts predict Model 3 efficiency issues will be largely resolved, with real-world ranges exceeding 400 miles through these combined advancements.